This question here asks us if x upon a is equal to y upon b is equal to z upon c. We need to show that x cube upon a cube plus y cube upon b cube plus z cube upon c cube is equal to 3xyz upon abc. This question was asked in the ICSE 2016 examination. Now remember one thing, generally if we've got multiple ratios equal to each other, or we've been given four terms are proportional to each other, we generally equate all the ratios to a common variable. So like in this case I can say let x upon a, which is equal to y upon b, which is equal to z upon c. I can say let that be equal to k, right? Now if you observe, that means each and every ratio is equal to k. So I can start by saying therefore x upon a is equal to k, right? And y upon b is also equal to k, right? And z upon c is also equal to k, right? Now what do I do with this information? It's basically what do you need. So what the idea here would be to rearrange this term, right? So I could say therefore if I'm to rearrange this particular equation here, x upon a equal to k, I can say x is equal to ak, right? So now yeah, and then I'll do the same thing for this second ratio as well. I can say y upon b is equal to k, so I can say y is equal to bk, right? And finally I can say that z upon c is equal to k, so z is equal to ck. And now this is the substitution that we're going to use in our proof. Okay, so let's start with that now. So generally whenever we have to prove something, whenever we need to prove we consider the two sides. So we have the left hand side and the right hand side. So the left hand side is equal to x cube upon a, so x cube upon a cube plus y cube upon b cube plus z cube upon c cube, right? So this is our left hand side. Let's make our substitution that we just figured out, that x is equal to ak, y is equal to bk, and z is equal to ck. We'll make that substitution over here. So this becomes x, instead of x now I have ak, right, and the whole cube upon a cube plus, instead of y now I have bk, right, the whole cube upon b cube, and instead of z I have ck, the whole cube upon c cube, right? Okay, to simplify this further, basically just opening up the brackets, ak the whole cube becomes a cube k cube upon a cube, bk the whole cube is b cube k cube upon b cube, and ck the whole cube is c cube k cube upon c cube, right? So as you must have already noticed, that terms which are common in the numerator and denominator, so let's just cancel those out. So a cube and a cube gets cancelled in the first fraction, b cube in the second fraction, and c cube in the third fraction. So now all that I'm left with is k cube plus k cube plus k cube, right, which adds up to 3 times of k cube. So this here is my left hand side, 3 times of k cube. Okay, now we need to do this. We need to do a similar kind of operation on the right hand side as well. Consider the right hand side, simplify it by substitute the values of x, y, and z, and then simplify it. So my right hand side, what is that supposed to be? So my RHS, right hand side is equal to 3 times x, y, and z upon ABC. So upon ABC, right? So once again we'll make a similar substitution. So we substitute the values for x, y, and z. This is equal to 3 times of again, instead of x we have ak, instead of y I have bk, and instead of z I have ck. the entire thing divided by A, B, C. Cool. Now to simplify this further, let's just open up all the brackets here. So 3 times AK, BK, CK will give me 3 times A, B, C. K into K makes it KQ. And the entire thing divided by A, B, C. So once again, if you see, there are common terms in the numerator and denominator. So the A in the numerator, denominator, B in the numerator, denominator, and C in the numerator, denominator all get cancelled out. All I'm left with now is 3 into K cube. So this, my RHS has also simplified to 3 into K cube. Right. So now let's just, now we are in our final stages of the answer. Let's just consider this, the LHS part, to be the first equation, right? And let's mark our RHS as our second equation, right? So now I can say that from equation number 1 and equation number 2, the left hand side is equal to the right hand side. Both of them are equal to 3k cubed, and that's what we need to prove. Right? So remember, whenever you're dealing with a question with multiple ratios equal to each other, all you need to do is equate it to another variable k, like we did over here, and then make an appropriate substitution and solve the sum.